Hello, I'm going to show you how you can measure camera alignment and also lip sync using an iPhone app from Hitomi. The iPhone app is called MatchBox Glass and you can just search for it on the App Store. It's completely free. Download it and install. Hold up your iPad in shot and then the Matchbox analyzer will do the measurements. I'll show you an example here. We've got a short latency camera. We've also got a high latency camera. An example when this might be done, it would be when a car comes into the pits in motor racing. It would have been shot by a trackside camera which has got a short delay on it because it's simply wired. But in the pit lane, for safety reasons, it always has to be shoulder-held wireless cameras, which of course have got encoding and decoding delays on them, all adding latency. So we've got a high latency camera. That's going to be our camera operator in the pit lane. Okay, so the car comes in. Let's just assume my clapperboard is the car. Have a look on that multi-viewer there. The right-hand view is camera 2, low latency, high latency, and the left one is the low latency. As you can see, there is quite a time delay. Those two claps are supposed to be coincident. So if you do a cut from one camera to the other, you would actually see the car come into the pits twice, which would not be very good for coverage. We could clap away and have somebody trying to dial in the delay, but it all takes time and it's not very accurate. The answer is to measure it, and that's exactly what we're doing here. Matchbox can see there's a latency on camera 1 of 538 milliseconds, whereas on camera 2 it's only 88 milliseconds. So we can make a correction factor. We can add some delay to camera 2 to match the latency of camera 1. Then when we do a cut between the two, it should look right. So I've got my calculator out. 539 milliseconds minus 87 is 452 milliseconds, the difference between the two. I've got a frame synchronizer here, which is not a Hitomi product, but it does the job. And we're going to add some delay onto camera 2 so we can match it up. .452 milliseconds. If we take another latency measurement, as you can see, it's got a lot closer now. These two cameras are free running, they're not locked together, so you would expect a little bit of a drift. I'm going to use my clapperboard again. You can see the clap happens at exactly the same time on both cameras now. All right, we have lined up our camera to camera. Our vision is good, but what about the audio? I'm going to turn up the speaker and say a few words into the microphone. Okay, assume I'm the reporter in the pit lane, doing his piece to camera, and you will see that the lip sync really isn't right. Is the audio coming ahead of the video, or the other way round? And by how much is it wrong? It's quite difficult to judge by eye. So let's do a measurement and see just how bad it is. So what you can see there is data, or here in fact, data in the audio. It sounds a little bit like a robot, but it has actually got information in there. So there's information in the audio and there's information in the video. Matchbox can make a measurement. Here we can see the delay is 394 milliseconds, that the audio is ahead of the video. That's why it seems so bad. Most people are used to hearing after they see something, if somebody's shouting at you from a distance, but if you hear before you see, it's very disconcerting. The human brain doesn't like it. So what we can do is we can fix that, but before we do, I'm going to show you just how accurate our system is. We have a ruler on the wall here, and the edge of my XLR connector is by 1 foot. I'm now going to move to the 5 foot mark. And you should see, if you look back onto the analyzer, our reading has changed by 4. So I'm not cheating, I put it back again. And sure enough, we're back to our 394 milliseconds. The speed of sound is approximately 1 millisecond a foot, and I moved it 4 feet. Okay, let's correct for that problem that we've measured. I've put in a delay of 393 milliseconds, and the glass reading is now showing 0. So that means that the audio and the video should be in sync. So let's try it out. Our cameras are now aligned, and our audio should be matching the video. So I'm going to say a nice favourite word of mine, starting with the letter P. Perfect timing.